Let's make sure we understand physically what's going on in this problem. There's a desire to add fluoride ion to the municipal water supply. The problem being that our supply has very hard water. It has a concentration of calcium 2 plus ion corresponding to 400 parts per million, which classifies it as very hard water. And in terms of molarity of calcium 2 plus, this corresponds to 0.01 moles per liter. So because we have calcium fluoride in solution, if we add too much fluoride ion, we're going to begin to precipitate out calcium fluoride. To get the fluoride ion into solution, we're going to add sodium fluoride. It's soluble, so this is going to dissolve. Every mole of sodium fluoride that dissolves will dissociate into 1 mole of sodium ions and 1 mole of fluoride ions. As we add sodium fluoride, the fluoride ion concentration increases, but we quickly reach a point where calcium fluoride will precipitate. We want to avoid that. Calcium fluoride will begin to precipitate out of solution when the ion product exceeds KSP. So the maximum fluoride ion concentration we can reach is when IP is equal to KSP. That's when we have a saturated solution. That's our equilibrium situation. Like all our equilibrium problems, we're going to start with an ice table and equilibrium constant expression. So here's our ice table. Calcium fluoride as a solid is going to be ignored. Calcium 2 plus has an initial concentration of 0.01. When S moles of calcium fluoride dissolve, we release S moles of calcium 2 plus and 2 S moles of fluoride ion. Since there's 0 concentration of the fluoride ion to begin with, its equilibrium concentration is going to be 0 plus 2S or 2S. The equilibrium concentration of calcium 2 plus is 0.01 plus S. As always, the equilibrium value is the initial plus the change. Here's our equilibrium constant expression, and we substitute in the relevant values. We want to check here to see if we can make the approximation, and it's going to be easy to make the approximation since the value of KSP is so small. 1,000 times KSP is 3.9 times 10 to the minus 8, and of course that is much smaller than 0.01. So we make our approximation, solve for S. Now that we have S, we can go back and answer the question. The question is, what is the maximum fluoride ion concentration? Maximum fluoride ion concentration is equal to 2S, so now we answer our question. And our final answer is 6.2 times 10 to the minus 5th moles per liter.